Okay, thank you very much. So I'm going to talk to you today about a study that we did within the SHAPE, so Sport Health and Performance Enhancement Research Group at Nottingham Trent University in the UK. By way of introduction, as we've already seen today, we've made this argument that successful sporting performance has got a substantial cognitive requirement. Okay, so to be able to perform sporting skills, we need a cognitive input. This study looks specifically at hockey, okay, but it's true across a whole range of sports that the major tournaments are often played in warm environmental conditions. Okay, so if we look at hockey, if we look at the 2008 Beijing Olympics, 2010 Delhi Commonwealth Games, and the World Championships having just been held again in India, the heat is clearly going to have an effect on hockey performance. Furthermore, linked in with the issue of heat is this issue of hypohydration or dehydration. Okay, and it's commonly suggested that this can reach 2% body mass loss in elite, and in this case, female hockey players. There's also some evidence that both heat exposure and dehydration can have negative effects on cognitive performance. Okay. Now, the literature is quite contrasting due to various different methods of heat exposure and methods of dehydration and cognitive tests used and their timing, etc., etc. Okay, but generally, there is the evidence tends to suggest either there's no effect or that there's in fact a negative effect. Related to that, exercise has also been demonstrated to affect cognitive function. Okay, again, it's a complex relationship, but overall, the evidence would suggest that certainly in an adult population, exercise is going to have a slightly beneficial effect. Okay, but again, it's complicated by what component of cognitive function you look at and the timing, etc., etc. However, the combined effects of intermittent exercise in the heat, so for example, playing hockey or football or anything like that, and the subsequent dehydration on cognitive performance have not been examined. Okay, so to try and enhance the ecological validity of some of the work, we aim to assess the effects of sport-specific intermittent exercise, so in this case hockey-specific exercise, performed in the heat, and the effects of dehydration on cognitive performance. Okay, so we recruited 8 healthy, unacclimatized to heat, elite female hockey players. By the term elite, they're international players with 2-3 years of international playing experience. Their characteristics can be seen in the table there, and they completed 4 different experimental trials. Okay, they conducted 2 trials in the heat and 2 trials in moderate conditions. So the heat was 33 degrees, moderate conditions 16 degrees. In both these conditions, they did 1 trial with and 1 trial without fluid. Okay, so giving us the 4 trials overall. Now, the exact experimental design is a little bit complicated, but initially they completed a battery of cognitive function tests. Okay, and I'll talk to you about those tests as I go through the results. They then underwent heat exposure, okay, and this was to induce dehydration. Okay? And you can see that on the condition where they would then be exercising in the moderate condition, they were in there for about an hour. When they would then be exercising in the heat, it was around half an hour. Okay, of heat exposure. The reason for that difference is overall we wanted the dehydration to be at about 2% body mass loss. There was then a recovery period followed by some intermittent exercise. Okay, and that intermittent exercise was the field hockey intermittent treadmill protocol. Okay. And that was developed based upon GPS analysis of elite level female hockey players. Okay, so it was to mimic what actually takes place in elite level female hockey. Okay. And you can see here we've got the various different running speeds, okay, and it was set into a pre-programmed treadmill. And on the laptop here next to a participant, it's telling them what they should be doing, whether they should be walking, jogging, sprinting, cruising, or at rest. Okay. Following that exercise, they then completed the battery of cognitive function tests for a second time. Okay, and we wanted to look at the effects of heat, the effects of dehydration, and the effects of exercise, all on the cognitive performance. Now, the first cognitive test that we used was something called a visual search test, which looks at perception. Right? It had 2 levels. Okay, on this baseline level here, triangles appeared on the screen, and the participants had to respond as soon as they see a triangle. Okay, so it's a measure of simple response times. On the more complex level, when we're looking at visual perception, so more complex visual processing, there was dots all over the screen, and when they began to form a triangle, like this one here, the participants were asked to respond. Okay, so this is looking at visual perception. To give an example from hockey, this might be, for example, tracking the position of the ball across the pitch along with the position of other players, both on your team and the opposition. What did we find? Well, we found that participants responded quicker in the heat. Okay, so a beneficial effect of heat on this visual perception. However, this was only on the complex level. Okay, so only on this more difficult level. And you can see down here, they're about 150 milliseconds quicker in the heat, okay, when compared to the moderate environment, but there was no effect on the baseline level. There was no effect, however, of hydration status, so no effect of the dehydration or of completing the exercise on response times. And interestingly and importantly, there was no effect of any variables on accuracy. Okay, so when we're looking at cognitive function tests such as this, we need to look at both speed and accuracy. Okay, because sometimes we'll see individuals get quicker. Okay, but is that just because they're pressing the button and looking away or they can't concentrate? Okay, so have we got a speed-accuracy trade-off? Okay, so we need to look at both response times and accuracy separately. The second test that we used is one that you may well be familiar with, the Stroop test, so a measure of attention or executive function, so kind of higher level cognitive processing. Again, it had two levels. On the baseline level, you had to select with the arrow key the word which matches the one in the middle, so quite straightforward. Whereas on the baseline level, you had to ignore what the word said and respond using the font color. Okay, so ignore the word. So here, the correct response would be green because it's in green font. We found no effect of heat exposure or hydration status on response times or accuracy. However, participants tended to respond quicker following exercise, but only in the heat. Okay, so again, we see here, following the exercise in the heat, they were about 50 milliseconds quicker, okay, but not following the exercise in a moderate environment. Okay, so again, a potentially beneficial effect of heat exposure. The final test was a test called the Sternberg paradigm, which is a test of working memory, okay, or short-term memory. Had 3 different levels, a 1-item, a 3-item, and a 5-item level. Okay. One letter would appear on the screen at a time, and if it's one of the target items, you responded pressing the right arrow key. Anything else, you responded pressing the left arrow key. Okay, so you've got to hold these items in your working memory and then compare them with what's on the screen. We found that overall, we had quicker responses in the heat, okay, by around 10 milliseconds there. Also quicker following exercise, okay, so about 20 milliseconds quicker following exercise when compared to before exercise. And interestingly, an enhancement of accuracy following exercise, but this was only the case in a moderate environment. Okay, so you can see here in the heat, they maintained between 96 and 97% accuracy all the time. However, in a moderate environment, there was about a 2% improvement in accuracy following the exercise. Okay, what does all this mean? Well, first of all, it suggests that heat exposure, okay, so being exposed to this 33 degrees temperature, enhances response times and or accuracy across a range of different measures of cognitive performance, okay, in these elite female hockey players. There was also some enhancement of some of the aspects of cognitive performance following the field hockey intermittent treadmill protocol, so following the intermittent exercise. But interestingly, there was no effect of the fluid restriction and resulting dehydration on any aspect of cognitive function. Okay, so it would suggest that in hockey players, we more need to be concerned about the heat, okay, and heat exposure than the resulting dehydration. Okay, this 2% body mass loss that we see here is similar to the level in the literature which is suggested to negatively affect cognitive function. Okay, but this study certainly wouldn't support that, and it would suggest that it's actually heat that we need to be more concerned about rather than the dehydration that results. Another point that I just want to add on to the end is these were high-level, international-level athletes. Okay? Would we see the same responses in amateur athletes or in novice-level athletes? There is some evidence in the literature to suggest that we wouldn't, okay, and that perhaps in novice athletes we would see a negative effect in the heat, okay, whereas in the higher-level international athletes we actually see an improvement in performance. Okay, the reasons for that we can perhaps discuss at a different time. Okay, hopefully I stayed within time. Thank you very much, and I'll be happy to take any questions.
Thank you very much. You did stay on time. Any questions?
The obvious question is, how hot were your athletes after the protocol, and what was the average intensity?
Yeah, so I didn't show the I didn't show the core temperature. I've got the core temperature data. I can't remember what it is off the top of my head. I think they were up at around 39.5. 39.5, so 39.5 at the end of the at the end of this, and that's the intensity which mimics international hockey.
And that was after 25 minutes of exercise?
They did 2 25-minute blocks. So in international hockey, again through that GPS study, they found on average 2 35-minute half players only play 25 minutes, which is why we did 2 25-minute blocks with a 10-minute block for half-time.
With your protocol, I was just wondering why you opted for a motorised treadmill-based protocol rather than an MNT, for example.
So, because we wanted to control the exact speed. Are you talking about a non-motorised thing where they control the speed? Yeah. We wanted to try and reflect what we'd seen in hockey play. Because obviously if you put them in there and you say sprint like you would in a hockey game, then maybe they would have issues with that.
I'm just thinking to draw out the experimental effect that you mentioned, because the protocol's not individualised.
Yeah.
When the people are sprinting 20 Ks for some of the elite females, especially with that height and size, height and weight, for example, that wouldn't be approaching their max speed. So the fatigue across the protocol may not be appropriate. That's why you've seen an augmentation of some of those responses.
Yeah, I think that's definitely something. So these the sprinting speeds, the jogging speeds, the cruising speeds could indeed be individualised in the future. Yeah.
Do you think your findings is a function of where you plant the cognitive tests? Because we know after exercise or even heat exposure, there's an arousal effect. So if your test were to plant it an hour post-exercise, would you think that you will see an effect on heat or exercise or even hypohydration?
Using data from another study which we've got where we looked at, so we dehydrated subjects the night before and then tested them before and after the exercise in the heat, and then again the following morning having rehydrated or not, and we didn't see any effects of the dehydration overnight on that, if that makes sense.
And my comment is, since the basis of this study, at least one of them is for ecological validity, it might be better if you plan the cognitive test during the exercise protocol than post, because that is normally what is required during the game, not after the game. And generally during exercise you'll see a greater facilitation of cognitive function as well. So you see an enhancement actually during the exercise rather than immediately post. Yeah.
I have a similar comment. We published some data a few years ago, similar data. We showed the opposite, that actually heat is detrimental for cognitive function. But we assessed it during the exposure itself. I was wondering, why did you choose to have the heat exposure, then recovery, and then the test itself, the exercise, and not, for example, exercise during heat exposure? Or at least, am I understanding it correctly?
I'm not sure.
The question is, why didn't they exercise during the exposure, like in the heat?
They did. Sorry, they did. So the hot or moderate down here, that reflects the temperature of during the exercise. So that's either 16 degrees C or 33. Yeah, so it is a bit complicated to understand exactly the protocol.
Thank you. Any other questions? Okay, thank you very much for sticking with us in this difficult hour, and we'll have a break and continue on a bit.